The second example, again, is another example where we can use the sum and difference identities of our sign in this case. It says electricity at alternating current I in amperes and another circuit can be found after t seconds using the formula I equals 2 sine of 285 times the time, where 285 is a degree measure. It says rewrite this formula in terms of the difference of two angles. So what we want to do is we really want to come back and rewrite the sine of 285 as the difference of two angles that we know exact values for. There are a couple different pairings that you can use to do this. We could use a pairing of 330, that's a known angle, and 45, and subtract those, and that would give us the 285. Another pairing would be 315, and then we could subtract from it a 30-degree angle and come up with the 285. So we have a couple different choices, and it doesn't matter which one you pick. You don't have to worry about picking the right one as long as they end up being a difference down to 285. So I'm going to rewrite this formula as I equals 2 times the sine. And now what we're going to do is we're going to rewrite 285 as the difference of one of these pairs. I'm going to use a 315 minus a 30-degree angle. That's the same as 285 times time. So we've just rewritten this formula in terms of a difference of two angle measures. And the two angle measures that we found were two angles that we do know the exact values of. So we're going to go ahead and apply the sign of a difference. So this is 2, and I'm going to use square brackets instead of a double set of parentheses. Hopefully it will provide a little bit more meaning and clarity. So the sine of the first angle, which is sine of 315, times the cosine of the second angle, which is 30, then minus, it's going to be the cosine of the first angle, which is 315, times the sine of the second angle, which is 30, times time. Now, a 315-degree angle, if you get our point of reference, is going to be a 45-degree reference angle in the fourth quadrant, so it doesn't look much like 45. It's 1 square root of 2. The only thing we got to be careful with is our signs on our trig function, because we're now in the fourth quadrant. So if we take the sine of a 315, which is the fourth quadrant angle, would be a negative square root of 2 over 2. Put in the rest as 2 times that. Then the cosine of a 30, well, that's going to be in a first quadrant angle. So if it's a 30, it's a 1, 2, square root of 3. So the cosine is the square root of 3 over 2. Minus the cosine of a 315. That's going to be just a positive square root of 2 over 2. Then the sine of a 30 is a positive 1/2 times time. Simplifying a little further, leave the 2 out there. Simplify inside the brackets, we have a negative square root of 6 over 4. Then minus the square root of 2 over 4 times time. And we can do one more, well, at least one more simplification. If we distribute the 2 and multiply both of these by 2, we'll have negative 2 times the square root of 6 over 4 minus 2 times the square root of 2 over 4. That's all times time. And then we can reduce our fractions again and have a negative. The 2 will go into 4 twice on the bottom, so it'll be a negative square root of 6 over 2. And this will do the same thing, minus the square root of 2 over 2 times time. And if one would desire, you could rewrite this as a negative square root of 6 minus the square root of 2 all over 2 times your time. Okay, so that is what I is equivalent to if we use our sign of a difference identity. Their follow-up question is fairly simple. They say, use your sign difference identity to find the exact current after 1 second. So what we're going to do is we're going to plug in 4 times the value of 1, which is no big deal because we know multiplying by 1 doesn't do a thing as far as changing our answer. So our final answer will simply be negative square root of 6 minus the square root of 2 all over 2. After 1 second, y will equal that. So another example of using sign of a sum, or in this case, the sign of a difference identity.